Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video, we are covering CCNA new topics that have been added to the exam 200-125. And this is section 4.4 eBGP. Upon completion of this section, you should be able to configure eBGP in single-homed remote access network. BGP overview. IGP and EGP Routing Protocol. IGPs are used to exchange routing information within a company network or autonomous system, AS. IGP stands for Interior Gateway Protocol. Now within the company, for example, say this is our company here. Within our company, we can use OSPF, we can use RIP, we can use EIGRP. So all these protocols, they happen within a company. Now each company, for example, imagine this is BT, Sky, O2, Virgin and so on. All the companies, especially the ISPs, they are identified by autonomous system number. So AS65002 here, for example, AS65003 for another ISP and so on. Border Gateway Protocol, BGP, is an exterior gateway protocol. This EGP used to route between the network administered by two different organizations. In BGP, every autonomous system is assigned a unique 16-bit or 32-bit AS number, which uniquely identifies it on the internet. The BGP updates are encapsulated over TCP on a port 179, inherit the connection-oriented properties TCP. So for example, the BGP doesn't have any reliability. Like for example, for reliability, it'll use TCP. TCP has a 3-way handshake and reliability is there. So it doesn't use any packets for reliability, for acknowledgement. Same as like OSPF has a packet, LSAC or EIGRP has acknowledgement packets. EIGRP doesn't use them, doesn't waste those packets. It has TCP for reliability. So within a company like this and this, within a company we use a IGP, Interior Gateway Protocol. But for example, if we want to advertise a network that is in our company to another company on another autonomous system number, we have to use BGP. And BGP is Exterior Gateway Protocol. Interior Gateway Protocol, there's few of them like RIP, EIGRP and OSPF. But Exterior Gateway Protocol, we have only one, which is BGP. BGP we go in more depth, a lot more depth in CCNP. But for CCNA, they kind of just explain, okay, well, at least they just explain Exterior Gateway Protocol. Now, for these two routers, to create an exterior, like a neighbor between the two routers, two different companies, one router cannot be in two autonomous systems. There can be only one. So you create the neighbors, you create them like back to back. Like this computer, this router on this company is connected and exactly to this computer on this company. So it has to be like a neighbor. It's not advised, you can, but it's not advised that you can make neighbors with somebody who's inside here. No, it has to be like next hop neighbor. There are two types of BGPs. First type is external BGP or eBGP. External BGP is a routing protocol used between the routers in a different autonomous system. So if we, for example, make neighbors with another company, with another autonomous system, that is considered external border gateway protocol. If you create a relationship within your company and you use BGP, that's known internal border gateway protocol. Internal BGP is a routing protocol used between the routers in the same AS. So same AS here, we have iBGP. Different AS, eBGP. This CCNA course, in this course, we are focusing on external border gateway protocol only. So when to use BGP? The use of BGP is a must appropriate when AS has connection to multiple autonomous systems. So if you, for example, you are this AS, usually ISPs, yeah, they have multiple connection to other ISPs, then they have to use BGP. This is known as a multi-home. Even if it's a single company, so let's say this company has got connection to this ISP, has got connection to this ISP, they can use BGP. Before running BGP, it is important to have a good understanding of BGP. Because, for example, take an example, this company here. He's running BGP. But as far as the other ISPs are concerned, this is just another external company. So here, the problem could be that this ISP could use our company, as a transit route to send packets to another ISP. So, for example, the customers of this ISP, they're talking to the customers of this ISP. They're using us as a transit route. Now that will be terrible, because we don't want our routers to be bombarded with so many traffic from internet. This doesn't even start with us or doesn't even end to us. It just starts with somebody else and goes to somebody else. And we are as a transit. So we want to kind of like stop this kind of transit packets. For example, another type, if we have connection to one ISP, we don't need to run BGP. We can just run like a static routing. So here, for example, BGP options, default route only. If a company has run, for example, has got connection, this company has got connection to two ISPs, so it's running eBGP, but it doesn't want all internet routes. It just wants a default route towards the internet. So it's got two default routes from two different ISPs. This is the simplest method. The second option you can have is when you have a default route and whatever the ISP route has. So for example, ISP advertises the default route and inside ISP networks. This will allow company A to forward traffic to the appropriate ISP for network advertised by the ISP. Suboptimal routing may occur for networks beyond connected to ISP. So for example, ISP will send you the default route plus whatever networks I have here. Same with the ISP2. Default route and whatever. Maybe this is a better ground, like a middle ground here, because you don't want this is too simple, right? You just have, okay, well, I'll do load balancing. Here you kind of say, okay, well, if the packets come from our company and they're going towards this ISP, I'll use this one. If they're going to this ISP, I'll use this one. Now the problem could appear that, for example, the ISP is here, the neighbor of ISP, one more here on the top, and you send in the packets this way and then going this way. So that's called the suboptimal routing. The last option is you get the whole internet routes. Now this is the most dangerous, because the whole ISP is going to take all routes from internet, hundreds of thousand routes, and it's networks, and it's going to network entries, and it's going to send them to you. So first of all, your router has to be very capable of holding all these routes on the memory, and do not try and do that. For example, you have to be careful that you don't become the transit route from the ISP. So from ISP 1, packets of customer of ISP 1 going to the customers of ISP 2, they could be trying to use our company to go to the destination. Steps to configure eBGP. First of all, we will go same as every other routing protocol. We go to the global configuration mode and we type router BGP. And then we need to tell our AS number. What is our AS number? Neighbor IP address. So because this is done statically, so there's no like hello messages and establish the neighbors dynamically with the BGP. BGP is very, very slow. We have to statically tell what is the IP address of our neighbor and what is their remote AS. If their remote AS is the same as our AS, then that becomes internal BGP. If their AS is different to our AS, then that becomes external BGP. And then we need to advertise the network. What networks do we want to send to our neighbor? Now, if the network that we advertise here is not in our routing table, it's not going to be advertised. You can enter it here as many times as you want, but it's not going to be advertised. We have to enter the network address, plus the mask. Exactly the same as the mask is being entered in the global configuration. This is a small sample configuration. I think we should do it. I think okay, let me have a look. This is what we were doing earlier, so I'll get rid of that with tunneling, yeah? So no more tunneling. Get rid of this. So what I want to do here is I want to create, for example, say this insert here. Say this is going to be ISP A, for example. send to back. So here, this is ISPA, and this is on this one here. Let me copy this. This is going to be ISPB. So I'll put this back as well. Send back. And the color, let's pick another one, yeah? Let's pick something else. The fill there. So this is ISP, say A, and here, this one here, I want it to be an ISPB, like this. So what I need to do, between these two routers, I need to create a BGP, and then making sure that well, we advertise some networks, yeah, so the other guys can see it, right? For example, ISPA, let's just imagine, has got let's pick one. What do we say? Let's pick one. I want to use. I don't want to use. I want to use a private because it's AS numbers. You know, the people that get picky. So I'm just going to use a private. The 65,000 is a private AS number, so that's what I'm going to use. So imagine that this is ISPA has an AS number of 65,000. That's a private, yeah. And ISPB we put here. Where is the mouse? Here. ISPB 65,001. Okay, so that's it. You can see all the information that we have here. So what I'm gonna do, the first thing is I should erase all this stuff anyway. So I'll go to router 2, Control Shift 6X to router 2, enable, exit from here. Let me get rid of the OSPF, just don't want to make a problem here. So no router OSPF 1, and I'm going to do that for all the routers. So Control Shift 6, router 4, exit, no router OSPF 1, router, what did I do? 4, which one was the first one? 2, router 3, config T, no router OSPF 1, and then router 1 as well. Config T, no router OSPF 1. Okay, so now we're gonna run EIGRP. So if I go to router 2 and say router router BGP, and then autonomous system number. Yeah. Statically, we have to say neighbor. So, for example, the IP address, either IPv6 or IPv4 address, but let's say an IPv4 because we're not running IPv6. So neighbor 10.1.23.3, this is our neighbor 10.1.23.3. Here we need to tell remote AS what is their remote autonomous system number. Well, their remote autonomous, it was 65001. 65001. Cool. We've done this. That's all we did. So if I do show run, for example, go all the way down, and not that far. Router BGP 65,000. BGP log neighbor changes. This is automatically there. Neighbor 10.1.23.3. This one. So it's like next hop, yeah, next hop address. They remote AS. So if I go to router 3 now, router 3, I say router BGP, for example, 65,001, and say neighbor 10.1.23.2 remote AS. They remote AS is 65,000. And now you can see that I have a neighbor change right here. BGP syslog 5 adjacency change, new neighbor 10.1.23.2. it's up, it's working. So we have external BGP neighbor. So show IP BGP summary. For example, we can see the neighbor 10.1.23.2, this one here, version 4, the neighbor's autonomous system number 65,000, and we haven't received any prefixes, so that's fine. If I go to router 2 and just check it, yeah, so go to router 2, show IP BGP summary. Again, I can see the neighbor 10.1.23, they autonomous system number, and that's external BGP neighbor. Show IP BGP, there's nothing. That's we see what's in our BGP routing table, or BGP table, and then the best route gets added to the routing table. Let's go to and advertise a network, yeah, on BGP. So router BGP. Now, if I put 65000, that's the OAS the router 2 is on. So if I put 6500001, you see, the router will tell me, no, you can't run in the 2 ASs. You have to be in 1 AS. That's it. So I have to put 65000. It's different to EIGRP. EIGRP you can put as many different as you want. It's not going to have a problem. So let's advertise the network. Let's advertise this network. 10.1.12.0 mask 255.255.255.0 end. Show IP BGP. Now the only reason why it's in this table is because we have that network. So if I went to advertise config T, say router BGP 65,000, and say network, for example, something that I don't have, 123.0.0.0 mask 255.0.0.0. I don't have this network. Even though I entered that, it's not going to be in my BGP table. It's not going to appear here. Unless you have it, it's not going to appear there. So that's my network. Now I'm locally connected. Next hop is 4 zeros, which is router 2. So if I go to router 3, I should hear about that network. So show IP BGP. As you can see, I've heard about the network 10.1.12.0, and I know that my next hop address is this. So if I say show IP route, I've learned the network through BGP, which is 10.1.12.0, and that's 20. The autonomous system is 20. So if we're learning about route, external route, then the autonomous system is 20. If we're learning about internal route in BGP, then the AS number is going to be 200. So internally, it's worse than external. So if for router 3, for example, if I say config T, create very quickly iBGP, router BGP here is 65001, that's it. I can say neighbor, and I'll put router 4 as my neighbor. So 10.1.34.4 remote AS is going to be the same one, 65001. So that's my configuration. So if I go to router 4, for example, run BGP here as well. So router BGP, I'll put the same number, 65001. Neighbor 10.1.34.4 remote AS 65001. Yeah, 34.3 I should have said, not 34.4. 34.3. That's it. Right, so BGP is very slow, but now we get in some fast messages, but very slow. So show IP route. Now I'm expecting to learn a route. This route, router 3 has learned about router 2, this route from router 2. That's external. But router 3 is going to send that route to router 4, and that's internal, right? So it's very slow. Yeah. Show IP BGP summary. Yep, we just received one prefix from 10.1.34.3. That's from my internal route. That says that they have typed network to put this route on the BGP. This route is valid. but it's not best yet. It's not been picked as the best route. So until we pick as the best route, we're not going to add this route to the routing table. It's not going to appear because you see the router 3 has advertised this network that he's learned, but he has not changed the next hop. Now router 4 does not know how to get to 10.1.23.2. So for that reason, it's not picking its valid route, but I don't know how to get there. So we can do two things. We can say to router 3, we can say, okay, neighbor. So when you say something to my neighbor 10.1.34.4, when you tell, you say next hop to be yourself. To change that next hop to yourself. Or we can do this, or we can go to router 4 and say, okay, config t IP route any network, right, with any subnet mask. We're gonna send it to router 1. Router 3. 10.1.34.3. Now router 4 knows what to do. Show iBGP. Now you can see that it's a valid. So I know how to get to this network. I'm just gonna send it to my default gateway. So when I say show IP route, now you can see that we have learned a route through BGP, but this is internal route. So that's why it's getting AS200. Okay. Here, let's go. No, we're not finished. I don't know if we're finished. Yep, we've done this. Show IP route, show IP BGP. We've done this. Show IP BGP summary. Show IP BGP route. So you can see the AS is 20. And the origin code B identifies that the route was learned through BGP. Show IP BGP shows the output of company A BGP table. First entry 00 is the default route advertised by ISP. And you can see that, and the second route is the network advertised by company A. So if you see the weight 32768 is the route that we advertise in. For example, if I go to, let me repeat this, go to router 2, say to router 2, show IP BGP, you can see that, okay, well, 32768, that's our weight, means this is a Cisco attribute. That means it's our route, we are advertising it. But if I go to router 3, for example, and show IP BGP, you see the weight is 0, which means that we are not advertising this, somebody else is advertising it. This I here says that, oh, whoever is advertising this route, which is this, has typed network. You could have other, for example, you could have a question mark, which is if somebody has redistributed a static route or something. Then E, if it's, for example, learned from EGP, which is a non-valid protocol anymore anyway. Show IP BGP summary, we've seen this. Okay, thank you very much for watching. Please have a look at my other videos and don't forget to subscribe. This has been Asir Krasniqi. BGP, you go in depth in CCNP. CCNA, that's enough. Bye bye.